Good evening, my dear students. Today I am going to discuss the topic called transformers EMF equation. So the topic is transformer EMF equation. So now to understand this topic, you should know what is transformer first. So I'll give you basic simple idea about transformer. Then we just move on to the main topic. So this is your transformer. Transformer works on the principle of mutual inductance, and the name itself it is indicating that the transformer is which transforms energy from one circuit to other circuit without any electrical connection. There is no electrical connection between your primary and secondary winding. You can clearly see here there is no electrical connection. So but based on magnetic medium, your transformer transforms energy from primary circuit to secondary circuit. So now let us see how it happens. See, first we are applying here sinusoidal waveform because this transformer works only on sinusoidal. This is I1, this is flux phi m, and if you connect any load here, so this is I2. Whenever the load is short circuited, then only current flowed from here. I mean the secondary circuit is short circuited, then only current will flow. So based on I2, again you will get some flux, and these two fluxes cancel with each other. The major neutralized flux is phi m. So that is other topic, but now our main topic is on EMF equation. So applying here primary voltage I1 from primary voltage induced here, again flux is induced based on which I1 and I2. So these are turns. N1 is the primary number of turns, and N2 is your secondary number of turns. Okay, so now what is EMF equation? So to understand EMF equation, we should know what is Faraday's law of electromagnetic induction first. So EMF is nothing but your electromotive force, which is nothing but voltage generated. So how voltage is generated in transformer? So now based on Faraday's law of electromagnetic induction, whenever conductor cuts the magnetic field, EMF is induced in the conductor. But now when you see this transformer circuit, there are conductors here. These are primary conductors and these are secondary conductors. So these conductors, whenever you apply the sinusoidal voltage here, you will get some type of magnetic field here, phi 1 here. So whenever this magnetic field cuts the conductor, EMF is induced. d phi by dt. The EMF induced in primary winding is given by minus N1 into d phi by dt. d phi 1 we will take here. But after cancelling all, we will get here phi m is the neutralized flux. So now let us see E1 equal to, we got here what, minus N1 into d phi by dt, right. तो ये देख सकते हैं आप, यहाँ पे ये चीज़ है कि साइनोसाइडल वेव है. The wave which you are applying input is your sinusoidal, and EMF is induced only for sinusoidal here, not for DC, because the thing is actually the conductor or your magnetic field, in both one should be time varying. So here the conductor is constant, the conductor is not moving, it is here only. But when you are applying the sinusoidal behavior of input, at that time what is happening? This flux is cutting here. So whenever time varying flux cuts the constant conductor, the EMF is induced in the conductor. The type of induced EMF is known as statically induced EMF. Statically induced EMF. So now let's see this diagram. This is flux phi m, maximum value of flux. and this is phi 1, this is omega t, this is t, and this is t by 2, and this is t by 4. So in this circuit where maximum value of flux is occurring here, phi m at t by 4. Can if you take it here again, here also you will get minus phi m. So now what we do here to find the EMF equation of the transformer, first what we will take here, E1 equal to d phi by dt. So what is d phi? Maximum value of flux, which is phi m, by rate of change of flux, maximum flux where it is at t by 4. But we are having other equation. There is an inverse relationship between frequency and time period. T equal to 1 by f. So phi m by 1 by 4f you will get. Finally 4f into phi m. So phi m is your flux density and f is your frequency. So now RMS value equal to RMS value by average value equal to form factor value equal to 1.44, 1.11, sorry 1.11. This is the major, one of the major equation which relates to your sinusoidal wave. RMS means root means square value and average value. So now by seeing this diagram we have find here which is your average value, which is d phi by dt. So RMS value equal to average value into form factor. So form factor is 1, average value we got it as 4f phi m into 1.11, which is 4.44 f into phi m. So it means E1 RMS. So this is the RMS value induced at primary winding, induced EMF. But now when you see there are other terms also, which is here N1. N1 is your primary number of turns. So what we do here, 4.44 f into phi m into N1. So primary number of turns N1 is, and similarly if you go for E2, 4.44 f into phi m into, next is your N2. So the major parameters here in transformer, V1 is your voltage at primary, P means primary and S means secondary I am writing, and V2 is voltage at secondary winding. So this is primary winding and this one is secondary winding. The winding which receives electrical energy is always known as primary winding, and the winding which delivers electrical energy to the load is known as secondary winding. By looking at these two parameters we can understand what is primary and what is secondary winding. So this is your major parts. Next is what we have discussed, phi m is maximum flux. So the unit is Weber and here volts. So phi m equal to A into B m. A equal to area of the core. This is the transformer core. Area is A. Transformer core. And Vm is your flux density. So this is flux density. And E1 is induced EMF in primary winding, and E2 is induced EMF in secondary winding. So this is the basic transformer equation which we can see on the board and which we have discussed today in the class. So the major equation of a transformer, one more is K equal to N2 by N1 equal to E2 by E1 equal to I1 by I2, which we call it as transformer ratio. transformation ratio. Thank you guys. Thank you for uh, listening my class today. Thank you, students.